So in the previous video, we got a basic introduction to the dot product, and one of the equations that I wrote down, or one of the definitions I wrote down, was that v dot u is given by the magnitude of vector v multiplied by the magnitude of vector u multiplied by the cosine of theta, the angle between them. And let's just roll with 2 dimensions for now. Hopefully you're okay with that because it's easier to visualize, and everything becomes more concrete right now if I was to just deal in 2 dimensions. And let's say vector u goes off like that, and of course we have a pointy end, vector v over here, and they're separated by an angle theta. Okay, so of course the dot product is useful because we can calculate what theta is, but what exactly, if I was to just give you just the dot product of 2 vectors, what good does that serve? Well, the dot product in itself can tell you the relative directions that each one is pointing. Notice that the larger the dot product is, the more like that they're pointing in the same direction. But also, what happens, tell me something about 2 vectors if u dot v is equal to 0, given that their magnitudes aren't 0. Tell me about the relative position of these 2 vectors. Okay, so if 2 vectors have a dot product of 0, I'll write this over here, it's kind of like a definition. If v dot u, these are 2 vectors, v and u, equals 0, and of course this is assuming that their magnitudes are non-zero, then theta must be 90 degrees, or they must be perpendicular to one another, or then theta equals 90 degrees, and u and v are said to be orthogonal. And that sounds like a scary term. V dot and v and u are said to be orthogonal or perpendicular. They're the same real meanings, but in just multivariable calculus we say that they're orthogonal. I'll write it over here, perpendicular, because they really are the same terms in 2-dimensional space. But yeah, just understand that if you have 2 vectors and their dot product is 0, then the angle between them must be 90 degrees, because cosine of 90 is 0. So if I put in 90 into here, this becomes a 0, and therefore the dot product becomes a 0. So if I give you any 2 vectors that have a dot product of 0, those 2 vectors are said to be orthogonal or perpendicular, meaning that they meet at a right angle. So this theta here, I didn't really draw it as them being orthogonal, but they would meet at a right angle. So let's do some practice with this idea of orthogonality. Let's say I give you 2 two-dimensional vectors, v and u, and let's say v is 4, 3, and I give you that u is equal to 1/2 comma negative 2 over 3. And I want you to tell me, are these 2 vectors orthogonal, parallel, or neither? So go ahead. Alright, if these 2 vectors are parallel, let's start off with parallel. If they're parallel, then you remember from an earlier video that they must be scalar multiples of one another. So that means essentially that v is equal to some scalar multiplied by u. Right? So that means if I was to find what v1 must be equal to, this scalar times u1, if this is true. So if I did v1 divided by u1, v1 divided by u1, I would get this c. And this is none other than just 4 divided by 1 over 2, or 8. So this is telling me that this scalar multiple would have to be c. And then if I was to do the same thing for v2 over u2, I would find that I would get 3 divided by negative 2 over 3, and I get a negative number, so I wouldn't get the same c. So therefore, since I don't get a constant c, they can't be parallel. So I know I can knock that choice out. They're not parallel. That much we know. Now let's see if they're orthogonal, and the way we would check this is using our definition with the dot product. I would have to find the dot product of these two. So let's go ahead and do that. V dot u is equal to 4 times 1 over 2. I'm going to keep doing this color scheme just so because it's an easy way to remember it. 4 times 1 over 2 plus 3 times negative 2 over 3. Right, let's math this out. So we get a 2 over here minus, these 3's cancel out, minus a 2, because it's just plus a negative 2, but if you want to say minus a 2, this becomes a 0. So we know that v dot u must be 0, therefore theta must be 90 degrees, and they must be orthogonal. Sorry. So that's our answer. Since the u dot v, or v dot u, equals 0, they must be orthogonal, according to our definition that we just went over to. So let's do one more. Let's say I give you two vectors. Let's do this one in a 3-dimensional space, u and v, and I tell you that u is equal to 2, negative 3, 1, and I tell you that v must be equal to, give me 1 second, negative 1, negative 1, negative 1. Little strange problem, but you know, negative 1. So they're, well, first off, pause the video, tell me if they're going to be parallel, orthogonal, or neither. Well, looking at them, they don't seem to be scalar multiples of one another, so they can't be parallel, so we can rule that option out. Next, we're going to check with the dot product to see if their dot product is 0. So let's do u dot v, or v dot u, it's the same answer either way. 2 times negative 1 plus negative 3 times a negative 1 plus 1 times negative 1, 1 times a negative 1, and we get a dot product of negative 2 plus 3 minus 1. So what do I get here? I get a positive 1 minus 1, and I get a dot product of 0. So once again, these two vectors must be orthogonal, meaning that they meet at a right angle. Essentially, if I was to, once again, just to drive this point home, u dot v, or v dot u, either way, let's just write v dot u for now. V dot u is given by the magnitude of v multiplied by the magnitude of u times the cosine of the angle between them. So if this value is 0, if this equals 0, then that means if these are non-zero, I can divide by them. I get that cosine theta is equal to 0 degrees. So therefore, theta must be no, cosine theta can't be 0 degrees. I apologize. Cosine theta is just 0. Then I get that theta must be 90 degrees. So if the dot product is 0, we say that the vectors are orthogonal or perpendicular to one another. It's a key concept. Study it, make sure you understand it, and I'll see you in the next video.